This is my final lesson for the Inferential Statistics for AQA Psychology series. It's just a brief one covering Type 1 and Type 2 errors. Even when a test seems to show a clear result, there's still a chance that the result is wrong. This lesson explains the two possible types of mistakes researchers can make when interpreting significance. Whenever a statistical test is carried out, there's always a possibility that the conclusion is incorrect. That's what Type 1 and Type 2 errors refer to. A Type 1 error happens when the null hypothesis is wrongly rejected, a false positive. It means concluding there is a significant difference or correlation, when in reality there isn't one. It's like saying to someone who is clearly not pregnant that they are pregnant. A Type 2 error happens when the null hypothesis is wrongly accepted, a false negative. That means concluding there's no significant effect when there actually is one in the population. In other words, this would be telling someone very pregnant that they're not pregnant. So in short, Type 1 is believing there's an effect that doesn't exist, and Type 2 is missing an effect that does exist. As a memory aid, I tell my students to think of the letter J in reject as a 1, linking to Type 1 error. So we wrongly reject the null hypothesis. And in accept, there's a double letter, 2 C's, which I link to Type 2. We wrongly accept the null hypothesis. The possibility that an error occurred can be determined by the margin between the calculated and the critical values. Let's take an example. A study looks at whether gender and preference for therapy are associated. A chi-squared test was performed. The critical value was 3.841. So for the chi-squared test, the calculated value must be greater than or equal to the critical value to achieve significance. If the calculated value of chi-squared was 3.90, just slightly higher than the critical value, researchers would accept the alternative hypothesis, saying that they found a significant association. Due to the two values being so close to each other, a Type 1 error is actually quite likely. A relationship was found that isn't actually there. If the calculated value of chi-squared was 3.60, just slightly lower than the critical value, researchers would accept the null hypothesis, saying that there was no significant association. Due to the two values being so close to each other though, a Type 2 error is likely. A relationship was not found when there actually might be one. So the further away the calculated value from the critical value, the less likely that an error occurred. The probability of making an error is actually directly linked to the significance level chosen for the test. If a test is carried out at p equals 2 or smaller than 0.05, there's a 5% chance of rejecting or accepting the null hypothesis wrongly. Type 1 errors, so wrongly rejecting the null hypothesis, become more likely when using more lenient significance levels, such as p equals 2 or smaller than 0.1, because the test allows more room, 10%, for chance. Type 2 errors become more likely with stricter significance levels, such as p equals 2 or smaller than 0.01, because it becomes harder to find significance even when a real effect exists. So, choosing a significance level is always a balance between being too lenient and too strict. This means that the likelihood of an error can be explored by changing the significance level and checking whether the result still holds or whether it changes. If the original result changes, for example, it was significant at 0.05 but not at 0.01, that suggests that the findings might be unstable and potentially due to error. If the result stays the same, it's less likely that an error has occurred. To check this, if the original result was significant, it would be compared to a stricter level, like p equals to or smaller than 0.01. If it was not significant, it would be compared to a more lenient level, like p equals to or smaller than 0.1. This is a simple way to test how robust or reliable a finding really is. This example shows how error likelihood can be seen by comparing calculated and critical values at different p-levels. If a chi-squared test produces a calculated value of 3.90 and the critical value at 0.05 is 3.841, the result is just significant, barely. This links to what we just discussed about errors being more likely when those values are close to each other. In this situation, a type 1 error is likely because if the significance level were made stricter, say to p equals to or smaller than 0.01, where now the critical value is 6.639, the result would no longer be significant. But if the significance level were made more lenient, say p equals to or smaller than 0.1, the critical value would now be 2.706. So the result would become significant, suggesting a possible type 2 error. The key takeaway is that results sitting very close to the critical value are more likely to be affected by sampling variation or chance. I hope this lesson helped you understand the difference between type 1 and type 2 errors and how to apply them to real data, or rather, the results from inferential tests. This also marks the last lesson of this series of lessons on inferential statistics for AQA psychology. Thank you so much for watching.